Okay, welcome to part 3 of this lesson on economics. And this is going to be about the idea of organisation in economic networks. So organisation means division into organs. So a good example is the organs of the body. So there are some organs of the body: the lungs, the heart, the kidneys, there are others. And the functions of the body are divided into these organs, which makes it an organism. The body is organized, divided into organs, and it exhibits organization, the property of having organs, being divided into organs. And the point of organs is that they specialize in certain functions and then they interact with each other, they support each other. So the heart pumps the blood around the system, the lungs supply the oxygen, the kidneys filter the blood for toxic substances. And if any one of these fails, it then affects the others, so that if there's problems with the kidneys, then the blood is not being purified, then it's less efficient at carrying oxygen to the heart, and without oxygen the heart beats less well, and that causes the blood flow to be more sluggish, affecting other organs and so on. So it's important for them all to contribute to the whole. If you take any one away, the whole system collapses. But the system is organized, it has organization, it is divided into organs. And we can contrast that with the very simplest multicellular organisms, as we might call them, sponges. In sponges, the individual cells, there's hardly any difference between them, whereas in an organized body, a heart cell is very different from a lung cell, is very different from a kidney cell. In a sponge, all cells are pretty much the same, even to the extent that you can take a sponge, a living sponge, and push it through a sieve so that it breaks it up into the individual cells. It doesn't kill it. The cells just come back together and reform as the sponge, because each cell can survive on its own. Whereas in an organised system, each cell can't survive on its own. Now, a similar process in the course of evolution, biological organisms have gone from a very lack of organisation to a very high degree of organisation. And what this means is they can operate at a higher level than the sponge. The sponge can only do things that any individual cell can do, but an organised body can do things that go beyond the capacity of any individual cell. It's more than the sum of its parts. And the same sort of thing has happened in social evolution. So in very simple societies, each person has in themselves all the skills and knowledge to survive in that very simple society. Everybody knows, how to get food, how to make their simple clothes, maybe how to make a bow and arrow. All the functions of that society are in each individual person. But in much more advanced, complex societies, they're like this. They've got institutions like banks and governments and the law courts. And these institutions make the whole system work. And so there is this high degree of organisation into these separate functions, and no one person has all the skills necessary to maintain the complex society. So a question is then, how can we measure organisation? And before I go on to that, I should emphasize here that I'm talking about this in terms of economics, because we're talking about specialization into heart, lungs, kidneys, and exchange between them. So specialization and exchange, a division of labor like this tells us that we're in the realm of economic activity. So yes, how do we measure organization as such? Well, one suggestion is to use the idea of entropy. So measuring it, entropy. In the mathematics module, we saw about entropy, how it's a measure of randomness or disorder in a system. It measures a lack of structure. We talked about how if you throw 2 dice, then if you score a 7, that's the highest entropy state because it has the most likelihood. And if you saw 2 dice showing a 7, you would think that they've probably just been chucked down because, you know, there's nothing special about showing a 7. But if you came in and saw the dice both showing 1 or both showing 6, you might think, oh, well, somebody's deliberately put them like that. There's more structure to it. So entropy measures kind of lack of structure. So low entropy would imply a high degree of structure. It's unlikely to have occurred by random chance. It's been deliberately arranged like that. So low entropy would imply high organization. That's one suggestion. Another one is looking at communications hierarchies, we could call it, or the author on this actually talks about dominance hierarchies. Dominance kind of implies more political relationships, coercive relationships, but what it's kind of related idea. And what he's talking about is if we've got a group of people in an organization, we look at who tells whom to do things. So we might find that, you know, on a particular day that Fred gives orders to Jim and Jim gives orders to George, let's say. And then if we come back tomorrow and we find that today Fred gives orders to George and George gives orders to Jim, it's changed around. And you know, we might come back the next day still and find that it looks like George, Jim, Fred. Well, this would suggest a lack of organization. It's a bit of a free fall. It's kind of arbitrary on any particular day who tells whom to do what. So they're not particularly organized into separate functions. Anybody can take charge of what they're up to. But if we find that it's more, you know, the next day it's Fred, Jim, George again, and that most of the time Fred is on top, and it's you know, can possibly be sometimes George to Jim, but most of the time Jim to George, then this implies a higher degree of organization. And of course, if it was the same every single day, that would be the maximum organization. It's organized into these separate roles which have a stable relationship. And you can measure this by a statistical metric called rank correlation. So the rank is 1, 2, 3, 1, 2, 3. Now you look at whether the ranks are correlated between them. So in the first one here, the rank 1, it is correlated, Fred to Fred. Here, Jim to George, well, that's not correlated in this particular instance. But if most of the time, you know, it's Jim to George or Jim, George to Jim or George, it's to some extent correlated. That's always correlated. You can calculate a coefficient for the rank correlation coefficient, for the overall similarity of the ranking. And of course this is just with 3 people, but if you've got hundreds of people in your system, you can compare the ranks all the way down, and the closer the ranking is, or the more consistent it is from time to time, then you would say you have a high degree of organisation. It's not arbitrary who communicates with whom, it's relatively persistent. And a third approach is by the anthropologist Robert Carnero, who came up with a list of organisational traits. So things like king and priest and potter. These are different types of role that you can have within, well, he was looking at simple societies, or simple to medium complexity societies. These are roles. He came up with a list of about 200 different types of organisational trait, where he said it is an activity within the society that involves 2 or more people working together. So a priest has a particular role, and other people who come into the ceremony have the role of congregation versus priest, and the king has a role vis-a-vis other people, and so does the potter, insofar as he or she is not making pots just for themselves, but is making them for the rest of the society. So these are activities that involve more than one person, and he would then just look at societies and count up the number of organisational traits they have. So the more organisational traits out of his list of 200, the more organised he would consider them to be. And he plotted population, in fact this is a logarithmic scale it's going to be, so the log of population versus the log of the number of organisational traits. So what he found was that there is some kind of relationship. So that's many different societies, their population and the number of organisational traits they have. And he found they tend to lie along on a log-log plot, a straight line with a slope of roughly 2/3. Or he proposed that it's actually 2/3. It was 0.65 or something, but he suggested it's probably 2/3. And so if we take it as 2/3, that would mean if the slope is 2/3, it means it's a power law, as we should remember from the mathematics module, log-log plot, straight line, power law, where then organisational traits O, if we write that, the number of organisational traits O is proportional to, if we use P for population size of the society, is proportional to P to the 2/3, the power law. And he said, well, that's interesting because in biology it's found that the brain size of organisms, B, we write B, is proportional to the mass of the organism to the power of 2/3. So that's provocative. It's like organisation of society somehow reflects its kind of brain power. It's the organisation that causes the society as a whole to be able to do complex things, and the higher the organisation, the more complex things that the society can do. And in the same way that the larger the brain, the more complex the organism. So population corresponds to the raw mass, and then organisation corresponds to the intelligence of the society or the organism. And he said that what would happen in a society is that if the population increases too much, So society with only this level of organisation grows out to here, it won't be able to cope. There'll be too many people, but it won't have the organisational features, traits to manage that size of population, to manage the conflict, for example, that occurs, or to be able to feed that number of people by, bringing in through trade food from afar. So if it does increase in population without the organisational traits, then it will inevitably break apart again, because it just wouldn't be able to live with that number of people without the suitable institutions, organisation for a society of that size. Okay, when we're talking about organisation, we're talking about networks, connected entities interacting with each other, because the whole point of organisation is that the different elements have to interact to make the whole thing work. They are organs within a larger whole. So here are some entities then connected with each other, interacting with each other, forming some kind of organised entity. And the strength of the links, or the number of links going into a node, tell you something about its importance in the overall system. The more things that are connected to it, you might think, the more important it is, because the bigger the problems if you take it away, because if you remove it, then a lot of links disappear, and many parts of the system will be affected. And also the links can tell us where the boundaries of the system are, because where they're weak, then it seems to be not an important part of this system. So here this is, or these entities are not really interacting very much with these ones, so they're not really part of the system. They're not organised within this network here. So we might say, well, that is one organism of organised entities interacting, and that is another organism of interacting entities, but the two things are largely separate. But nevertheless, they are connected, and so we could see that this entity here, this system as a whole, is connected to that system as a whole. So these are like entities in a higher level network that are connected. So there are different layers of organisation. This is organised within itself, but is part of this higher organisation between these two separate systems. And we're going to explore that idea then in a bit more detail, that there are different layers of organisation. Okay, this is supposed to be the United States, and there's a website called Where's George that studies the movement of dollar bills. So it's referring to George Washington on the US dollar bill. And on the website, if you have a dollar bill, you can go and enter the serial number of the dollar bill and say the date and where you saw it, where it came into your possession. And people have, so through that you can then see if other people have also entered that same dollar bill into the website, the movements of the dollar bills. And people have studied these, the data, and they've found that the US divides into a number of sort of regions, and they look something like this, that dollar bills tend to move within these regions, but they don't go outside them. So if you see a dollar bill here, and later on it will be moving somewhere around, but always within this region, it's very unlikely to move to these other ones. And similarly, a dollar bill here moves around within that region, but very unlikely to move outside it. So it seems as though the US divides into a number of regional economies. This economy has everything that the people within it need. They only need to circulate their dollar bills within that economy. It's got all the goods and services that people require. At least it is the regional economy at the level of dollar bills. The kinds of things that ordinary people exchange cash for, goods and services. But of course there is a high level of trade within the US, across country and between these regions. But this tends to happen at the level of big firms transporting large consignments of goods cross country. So there might be trades like this between the regions, so they form another kind of network. But these don't show up on Where's George because they're not paying cash for these consignments of goods. It's happening at a higher level, electronic exchanges within the banking system. So there is a regional economy, or several regional economies, and then so they form networks of their own, and then they are a part of a higher level economy involving interactions between the regions. And we know that this involves organisation, a division of labour and some kind of specialisation, because there would be no point in moving goods from there to there unless they were goods that weren't already there. So there must be some kind of specialist goods, or a particular type of breakfast cereal or something that's made here and isn't available there. And similarly, this region must have something unique that this one wants, because no one would keep shipping goods that way unless there were some goods coming back the other way. So so that these regions are economically specialized on a higher level. They're part of this bigger network of organization. And people have seen the same sort of thing in the ancient Mediterranean. Okay, so these are some villages or small towns within the ancient Mediterranean, and they're on little islands or the coasts around the Mediterranean. And people have reconstructed the trade links between them. And there are various approaches to that. In the mathematics module, we looked at a couple using entropy maximization. So finding the most likely configuration subject to certain principles and rules. There was one that used a Hamiltonian, which defined a kind of energy function, which is a Hamiltonian, and then minimized that energy. Energy depended on, it was increased by population size and decreased by availability of goods, for example. Other simpler approaches are what's known as proximal point analysis. So for this, it's just assumed that sites were connected to their closest neighbours, proximal points. And you choose a value, let's say they're connected to their 3 nearest neighbours. You look at the network that way. And another is maximum distance network approach, where you say that each site is connected to all the other sites within a maximum distance. So you might choose 10 kilometers or 100 kilometers, and then you construct the network that way. But so what people have found is that in very early times, these networks consisted of links between pretty equally sized sites, and they were just trading fairly locally. And each site then was pretty self-sufficient. They didn't really depend very much on the trade they got from the others. It was a fairly low-level sort of trade. But as time went on, the network became more organised. So let's have a look at that. I'll use the same sites, I'll just draw them underneath. So what they find is that the structure moved to something more like this. Whereas this can be called a many-to-many network, this is a hub and spoke network. So these large ones I've shown are the hubs, and then they're connected by spokes to the smaller villages. So these are sort of big cities and smaller towns or villages around them. So the links between these sites have disappeared, and they're more linked to the hub. And then the hub trades with this other hub, and that hub then communicates down to its little local sites. So the movement of goods from here to here goes up to the hub, to the next hub, and then back down, as opposed to here where it goes along a long trail of links. And in this case then we've got these similar regional economies. That hub serves its local regional economy, a bit like over here. It's split into these two regions, and then those regions communicate at a higher level with this much bigger movement of goods between them. So much larger scale operation of big ships and big businessmen organising that trade. And as the Mediterranean evolved, or the Mediterranean trade network evolved from this many-to-many level of organisation to the hub and spoke, a more organised structure, ordinary people became more dependent on trade goods. So here, I said originally that each village is much the same, and they rely largely on their, what they can do for themselves. Trade isn't very important to them, and these trade connections were mostly of concern to the local kings and rulers, the elites in these different villages. So what was moving along these trade links was not corn and oil, things that were used by ordinary people, but gold, diamonds, precious things. And down here, though, as it moved to this hub and spoke, ordinary people did now become much more involved in trade, and they were using products that were made hundreds of miles away and communicated through this organised trade network. So increasing organisation brings greater economic activity and prosperity, really, to ordinary people. Now, later in ancient Mediterranean history, in the time of the classical Greek civilization, a lot of these trading cities established colonies elsewhere around the Mediterranean, in the Black Sea and in Italy particularly. And we can assume that the more important, bigger trading cities establish established more colonies, because some establish more than others, and it makes sense that the biggest, most important ones established the most colonies, because they established the colonies so that they had people that they could trust, that they could manage their trade at the other end in other parts of the Mediterranean. And we can therefore plot, and this will be a rank size plot, of the number of colonies of different Greek cities against rank. And we covered this in the lesson all on scale-free phenomena and power laws in the mathematics module. And what you find is on a rank size plots from the city with the most colonies down to the lower ranking cities who had fewer colonies. On a log plot, you get a straight line. So straight line tells you it's a power law, and the fact that the cities all tend to lie on this same power law suggests that then they're part of a system. So this Mediterranean-wide trade network was a system from larger hubs down to smaller ones, but they were all connected and interdependent. If they had not been part of a larger system, you would expect them to be similar in their size. Each one would serve a particular region, but it wouldn't, if it's not connected to the others, then each region would have a largest city, but within each region it would be the largest, but they would all be the same between the different regions. But because the regions themselves are connecting and interacting with each other, some of them emerge as the hubs of the hubs, and so you get really big ones and lesser hubs, and that's why you've got this power law relationship from the really biggest hubs up here to the smaller ones, lower ranking in terms of their size. And we see the same in the international system today, this regionalization of world trade. Okay, so in world trade today, countries tend to trade within regional trading blocks. Trade links tend to be strongest if they're geographically close countries, if they have mutual trading partners. So if country A trades with country B and also trades with country C, then B and C are likely to trade with each other. So if they've got the same trading partners, then they'll also trade with each other. And lastly, GDP is also a factor. So the most prosperous countries trade with other more prosperous countries and less likely to trade with the poorer ones. So all these factors tend to create regionalization within the world economy. So goods circulate within these large geographical regions or cultural regions, they might be, within the world. And then those don't actually trade so much with each other. But nevertheless, there is trade between these regions. So, you've got places like Shanghai, Los Angeles, and Rotterdam. These are the major world ports, and they form a network. So they are like the hubs and spokes of the ancient Mediterranean. So this is the highest level of organization within the world economy. And then there's a lower level organization within regions, and then within countries, and then each town is a bit of an economic network of its own right. So there's organization on multiple layers. And the sign of this multi-layer organization is the existence of this hub and spoke structure. So the hub communicates within its local network, and then it participates in this higher level network, but only communicating with other hubs.